So our homework 1, you can see here we have the answers for number 1 and 2. If you have either of those ones incorrect, you're going to want to keep watching the video. So let's see how to do number 1 and 2. Okay, number 1, a grinding wheel of radius 0.35 meters. So we know that that is our distance or our radius, 0.35 meters. It says a grinding wheel of radius 0.35 meters, rotation on a frictionless axis is brought to rest. So basically it's rotating and it's brought to rest by applying a constant frictional force tangential to its rim. So if this is our rotating grinding wheel, let's say from the top, tangential to it is basically tangent to the circle. So somewhere on here there is a force, whether it's here or whether it's here or whether it's here or whether it's this way, who knows, right? But if it's rotating, it's tangent to the rim. The constant torque produced by this force is 76 newtons per meter. Find the magnitude of the frictional force. So we said that this frictional force is acting on it and we want to find it. So we know that the torque that changed that rotation equals the force, right, that is tangent to it, times our distance or the radius or the distance away from the point of rotation. So our torque is 76, right? We're looking for that force. Our radius is 0.35, and so 76 divided by 0.35 gets us that answer we're looking for, 217.14 newtons. So a frictional force of 217.14 newtons will cause this torque, causing it to change its rotation or slow down in this case. Looking at number 2, right, according to the manual of a certain car, the maximum torque of magnitude 65 newtons per meter, magnitude just means without direction, should be applied when tightening the lug nut on the vehicle. If you are using a wrench of length 0.35 meters, so that's our distance, and you apply the force at the end of the wrench at an angle of 75 degrees with respect to a line going from the lug nut through the end of the handle. Okay, that's a little confusing, right? So we have our lug nut. Not a very good artist here, right? And so we're going to have our wrench around this lug nut. I couldn't be any worse at this. There's our lug nut and our wrench, and it says that it's applied at an angle of 75 degrees with a line going through the lug nut and through the end of the handle, right? So through the lug nut and through the end of the handle. So from that point, we are applying a force at this 75 degree angle. Well, if you remember from the notes, the only thing that applies torque is stuff that is perpendicular to the way it rotates, right? So if it's rotating this way, it's kind of like that last one. It's tangent to that circle, or it's perpendicular to that line through the lug nut. So we only want the component of that force, right? This, in this case, the y component, and it is opposite of the angle, which means we are using sine, right? So the sine of 75 degrees is the y component actual over the actual hypotenuse, which would be the force that we were applying. Well, torque is not just Fr, but it's also written as Fr sine theta, right? And the reason why it's sine theta is because of that force. It really should be written, it would make more sense to write it like this, because this F sine theta is because of this situation where we want this y force that's pushing perpendicular to it. So we've got a torque of, right, we have this torque of 65 newtons per meter. We are looking for the force that was applied to it at a sine of 75 degrees, and the distance away from it is this 0.35 meters. And so we're able to solve for F, and that gets us our answer of 192.27 newtons. Right, so this force here was 192.27 newtons, and it applied this torque of 65. And that's it for number 1 and 2.